Hey everybody, it's Mr. N here, and this is a review video on derivatives and integrals of logs and exponents. So let's go ahead and get started with the first problem here. And this one says y equals e to the 2x cubed. So we have to take the derivative with respect to x. So on this, we have dy dx equals, and we take the derivative of e to the x, which is just e to the x. So in this case, it'll be e to the 2x cubed, and then we need to employ the chain rule here, which will give me 6x squared. So our final answer is dy dx equals 6x squared times e to the 2x cubed. All right, working for the next one, number 2, y prime. Now remember, the derivative of natural log is 1 over x. So in this case, we will have, this is the ln natural log of the natural log of that. So this will be 1 over ln 2x to the 4th. Now we need to chain rule this part. So that'll be 1 over 2x to the 4th. So I'm taking the derivative of this ln right here. Let me show it to you. I'm taking the derivative of this ln 2x to the 4th, and that's what I get. And now I need to chain rule it one more time. So this will be times the derivative of this part right here, which will be 8x cubed. So now I can clean this up. A few things reduce here. I can reduce this with that, make that a 4. I can go ahead and reduce this with one of those. You'll still have 1 on the bottom. So your final answer will be y prime equals 4 over, and that'll be x, this remaining x, times ln of 2x to the 4th. And that's a 4, if you couldn't tell. Okay, so now moving on to the next problem. For this one, we have y prime going to be equal to, okay, so e to the x is just e to the x. So again, this will be e to the 3x squared. Now I need to take the derivative of that, which is part of the chain rule, that which will be e to the 3x squared, and now I need to chain rule that part, which will be times 6x. There's nothing left to take the derivative of. Sometimes we get confused with how far do I take the chain rule out, but that's it. I did this part right here, and then I did this part, and there's nothing left to take the derivative of, so I've done it all. So now it's a matter of cleaning this up. So what I can do is, let's go ahead and put the 6x out in front. And now I've got this right here. Well, they're both e to the x times e to the x. So I could just put one e and add these two parts over there. So I'll end up with e to the 3x squared plus 3x squared. I could simplify it like that. All right, moving on to the next problem. For number 4, again, it's the same concept. We're going to take the derivative of e to the x and then use the chain rule. So we have y prime equals e to the x, and in this case that'll be 4x cubed plus 5 squared times, we have to chain rule this. So to chain rule this, we need to do this part first. So 2 times the 4x cubed plus 5, now that'll be to the first power, times, now we got to chain rule that. 12x squared. There's nothing left to take the derivative of in the chain rule, so now I'm done with the chain rule. And now it's just a matter of cleaning this up, and we're going to say that this is 24x squared times the 4x cubed plus 5 times the e to the 4x cubed plus 5, that quantity squared. All right, moving on to number 5. So for this one, I had changed it on your worksheet. Let's go ahead and change it here because I wanted to give you more trig ones as well. So this one, I had changed it for you guys to say cosine of the natural log of 4x cubed. So let's go ahead and do that. I realized after I made this worksheet, let me put a couple more trig ones in here. All right, so to take the derivative of this, the derivative is a derivative of cosine is sine. So y prime will be negative sine, derivative of cosine is negative sine of this, which is ln 4x cubed. Now I need to chain rule this, so the derivative of natural log is 1 over 4x cubed, and now I need to chain rule this. So that'll be 12x squared. There's nothing left to take the derivative of, so I completed the whole chain at this point. So we end up with y prime being, let's clean this up. This will reduce with that to make it a 3. This with one of those, with two of those. So it'll end up being negative, and this will be 3 sine ln 4x cubed, and on the bottom you'll have just that x. All right, moving on to the next one. For this one, we have e to the x on the top, e to the x on the bottom. We are going to need a quotient rule, but since they're both e to the x, I can rewrite this and not have to use a quotient rule. So check this out. I'm going to go ahead and say this is e, and on the top I've got 5x to the fourth. Well, they're both e to the something, so I can subtract what I have on the bottom, and in this case, this will be subtracting 4x squared plus 3. So I can take the derivative of that instead to make the problem a little bit easier. So in this case, we'll have y prime as being e to all that. So that'll be e to the 5x to the fourth minus 4x squared minus 3 times, now I need, this is the derivative times this stuff up top, which will give me 20x to the third minus 8x. And now it's just a matter of rewriting this. I can even probably take out something here if I wanted to simplify it a little bit further and clean it up. So I could take a 4 and an x out. And I will be left with the 5x squared minus 2 times this e to the 5x to the fourth minus 4x squared minus 3. All right, moving on to number 7. So let's slide this up. And let's take a look at this. So in this case, I will take the derivative, and over here I have to, at first it looks like I have to use a product rule, but I don't. E squared is a constant, so I could just leave it like that. So that'll just be the derivative of a constant times x is just the constant. So in this case, it'll just be e squared minus, take the derivative of that, it's just e to the x times 1, right? Chain rule it. So we end up with y prime equaling e squared minus e to the x. Okay, next problem. Over here, we end up with y prime equaling, now this can be, think of it as 10x to the negative 1. So the derivative of the natural log will be 1 over 10x to the negative 1 times, this will be negative 10x to the negative 2. So we can clean all this up. This 10 goes with that 10, and this x squared will come down to the top. This x will go up to the top. This will come down to the bottom. So it'll just leave me with negative 1 over x when all is said and done. Okay, for the next one. For this one, we got to take a look at our rules again and see what we have here, and we have y prime. Now remember, the derivative of a logarithm, so d dx, again, you really should, as you're doing these, until you've memorized all your formulas, have that formula sheet I gave you out in front of you to help you in case you can't remember. So the derivative of log base a of u is 1 over u ln a times du dx. So that's what we're going to use here. So in this case, this is log base a, and there's my u. So when I take the derivative of this, I'll end up with 1 over 3x squared times ln 3, because that's my a, times, now I have to take du dx, which means take the derivative of that. That's the chain rule part, which will be 6x. So I can clean this up a little bit. One of these x's with one of those, this 6 with that 3. So I end up with y prime, that's going to be a 2. So that'll be 2 over the x ln 3. Okay, number 10 is the same type of problem. We have the same formula for it. So again, let me write it here. The derivative will be 1 over u ln a times du dx. And in this case, that's my a and that's my u. But don't forget, you have that going on there too. So y prime will be 1 over negative 5x cubed minus 2 to the third times ln 5 times, now I have to take the derivative of this part, that's the chain rule, and in this case it'll be 3 times negative 5x cubed minus 2 squared times negative 15x squared. So that's what it'll look like when all is said and done. And we can go ahead and simplify this. So y prime equals, now this will reduce with 2 of those. The 3 and the negative 15 will be negative 45. So I'll end up with negative 45x squared all over. I still have one of these on the bottom with the ln 5. All right, number 11, here we go. Let's take a look at this. This is the derivative of a to the x, right? Or we could say a to the u in this case. And we said that the formula for this one is a to the x ln a. And then if we have a chain rule, we have to multiply that chain rule part. All right, so let's do this. So y prime is going to be a to the x. So this will be 3 to the x fourth plus 1 cubed times ln 3, and now I have to chain rule this part, which will give me 3x to the fourth plus 1 times 4x cubed. Cleaning all this up, we end up with y prime equaling 12x cubed ln 3. I got the 12 from here, and there's the x cubed, and there's the ln 3, times 3 to the, 3 to the x fourth plus 1 cubed power times this x to the fourth plus 1. Actually, this would be a squared. I just realized I didn't put a squared there. This is squared. All right, moving on. Let's see what we got next. This time we're going to take integrals. All right, so again, it's helpful if you have your formula sheet next to you so that we can take these integrals and you can refer to the formulas as needed. For this first one though, let's go ahead and let u equal this 4x to the fifth plus 3 and see what happens. We'll use a substitution rule here, and again, if I pick the wrong one, we have to redo it. So du equals 20x to the fourth times dx, which tells me that du over 20x to the fourth is what my dx is going to be. Let's substitute this in. So I have 20x to the fourth over u times the du over 20x to the fourth. Those will reduce, so I end up with the integral of du over u. And that's just, remember, the integral of 1 over u du is ln u. And we have to put the absolute values on that. So this will be ln absolute value of u plus c, right, plus c in our formula there, which gives me ln absolute value of 4x to the fifth plus 3 plus c. All right, moving on. For the next one, let's go ahead and, well, let's try this. Let's let u equal the negative 1 plus ln 4x. Now, remember, whenever we do substitution, we try to pick the thing that's most complicated, or at least that looks most complicated. That's the one that looks most complicated. So du equals, taking the derivative here, I'm just going to end up with 1 over 4x, because the derivative of that is 0, times 4, using the chain rule, times 4 dx. So those will reduce. So I end up with x du equals dx. So let's substitute this in. So I have the integral of 2 over x times u times, this will be x du. Well, those reduce out. So I end up with 2 times the integral of du over u, and that's just 2 times ln absolute value of u plus c. Let's make our resubstitution, which will end up being negative 1 plus ln 4x plus c. All right. Moving on to the next page. Let's take a look at what we have here. Let's zoom in on this a little bit. Move it down so we get a better look at it. There we go. Okay, for the first one here, the integral. Let's go ahead and let's let u equal that 5x to the fourth minus 2. That one seems the most complex to me. So let u equal 5x to the fourth minus 2, which would put du at 20x cubed dx. So du is 20x cubed over 20x cubed is dx. So we end up with the integral of 80x to the third times, this will be 3 to the u, and du over 20x cubed. Well, those reduce. This reduces with that to make that a 4. So I end up with 4 times the integral of 3u du. Again, this is a constant, so that 4 is a constant, so I was able to put it out in front. And this ends up being a formula that you need to memorize. The integral of a to the u du, we had talked about this, is, it's on our formula sheet, is a to the u over ln a. So let's go ahead and use that. So this will be 4, and now this will be a to the u, so this will be 3 to the u, so times 3 to the u over ln 3 plus c. Let's make our resubstitution, so 4 times 3 to the 5x to the fourth minus 2 all over ln 3 plus c. Okay, going to the next one now. So for this one, again, it looks a little complicated. Let's go ahead and let u equal, this one's going to be tough to choose. So I'm going to choose this because it's the power. I'm not going to choose the sine one. I'm going to choose I'm going to choose the one that's the cosine negative 2s because it's that power of e. So let u equal cosine negative 2 to the x. So let's see if that works out. Du equals negative sine of negative 2x times negative 2 dx. So du over, this will be positive 2 now, sine of negative 2x equals dx. Now let's substitute that in. I end up with 10, and this will be sine negative 2x times e to the u times the du over, because I'm substituting in the dx, 2 sine negative 2x. That reduces with that. This will reduce with this, so I end up with 5 integral e to the u du. So, integrating this, and it's just the integral of e to the u, which is e to the u, plus c, I'll end up with 5e to the u plus c. Resubstituting, I end up with 5e to the cosine negative 2x plus c. All right, so now for number 16. For number 16, let's go ahead and let u equal the e to the 5x, and let's see if that works out. Du will be equal to e to the 5x dx. Oops, I forgot to chain rule that. E to the 5x times 5 dx. So this ends up being du over 5e to the 5x is what my dx is. And let's do some things here. Let's see what we could do. This will be 20. Now, I'm going to keep this. If I substitute in that u right up top, I might have, if I try to substitute the u in right here, I'll end up with a u on top and a u on the bottom. So let's just do the one on the bottom because we're adding something to it, and then just see what ends up happening here. So in other words, I'm trying to tell you, just keep this as e to the 5x. That way you don't have u over u plus 3, because then see how we end up with the u on, and we can't really do much with that. So instead of having that happen, I'm just going to substitute the one on the bottom. So this will be u plus 3 times, now let's substitute in the dx, which is du over 5 e to the 5x. And now what ends up happening is those will reduce out. This will reduce with that to make it a 4. So I end up with 4 times the integral of du over u plus 3. And that kind of worked out a little bit better for me. And this will end up being 4 times the natural log of the absolute value of u plus 3, right? Because du over u, the integral of that, is ln, absolute value of u. Okay, plus our c here. Now let's make our resubstitution, which is e to the 5x plus 3 plus c. All right. Moving on. Let's see what we got here now. For this one, let's break this apart. This one might be kind of tricky to you because you've been used to all these other ones right now, but let's just rewrite this. This will be the integral of 4/3 t to the negative 2 plus 7/2 t to the negative 1 dt. All right, well, this is an easy problem to integrate for these. For this one, it's just going to be negative 4/3 t to the negative 1. For this one, I'll have the 7/2, and I'll have to, since it's t to the negative 1, which is 1 over t, I need the ln. So this will be the ln absolute value of t plus c. And there you go. You can rewrite this to be negative 4 over, you can rewrite this part to be negative 4 over 3t if you would like. That's okay as well. All right, let's move on to the next problem and see what we have here. All right, we're down to our last 3 problems. For this first one, we have the integral of, and this is again kind of like the other one. Let's just rewrite it. So we'll say 5, this is y to the 1/2, plus 3, this is y to the negative 1/2 dy. And let's see what happens here. Okay, for this, I can integrate this one, and this will be y, so if I add 1 to the power, this will be 3/2. So that means I need a 10/3 out in front to get 5. Plus, again, this one, I add 1, so it'll be y to the 1/2. And since I need a 3 out in front, I'll have to make this a 6 plus c. You can rewrite this if you want to say 10/3, the square root of y cubed, plus 6 root y plus c, if you wanted to simplify that like that. All right, let's see what we've got for number 19. Number 19, okay, here I could break this whole polynomial apart. I told you we did in class, if say this said 2x plus 1 on the bottom, you would have to use polynomial long division. But since this is just a 2x, what I can do is I can break each part of it apart like that. 1 over 2x. So each part of it I can separate out, and this will be dx. And now I can integrate every single one of these separately. Let's reduce it first. So this will go with one of those. Those will go away, and that'll stay like that. So the integral I'll end up with will be, let's write it nice and clean, 3/2 x plus 2 plus 1 over 2x dx. And we integrate this. This will give me 3/4 x squared. This will give me 2x. And this one will be the natural log. And I'll just put that 1/2 out in front, and I'll say ln x plus c. And that's your final answer there. And let's do this last one. All right. This is a constant when you take a look at it. This, I can integrate each separately. So this will be 5e to the x. Since that's a constant, that's just going to be x times the e plus c. And you are all done. So hopefully this review has helped. Just be aware of the different situations that you might encounter and use the substitution rule as needed, and make sure you use that formula sheet and memorize those formulas. All right, thanks for watching. We'll see you in class.